Hey everyone, welcome back to the channel. In our last video, we built a machine learning model to predict California housing prices using XGBoost. We improved our R square score from around zero point 0.8 to 0.84, but many of you asked, can we push it to zero point 0.9? So let's find out. Today we will explore why reaching zero point 0.0 R square is difficult for this dataset. We will also discuss feature engineering, model staking, and advanced techniques to maximize accuracy. Before we start, don't forget to like, subscribe, and comments below if you have any question. So, why can't we reach zero point 0.9 R square? So, the dataset has a high variability and noise. The California Housing Dataset is from the 1990 census, so it's a very old dataset. It doesn't account for modern factors like inflation, economic shifts, or urban development. Missing data makes it impossible to model price variation perfectly. Even the best model can't explain 100% of the variance due to missing key factors. The datasets lacks critical real estate features. The real estate prices depends on square footage of the house, number of bathrooms, crime rate in the neighborhood, proximity to schools, hospitals, transports, air built and renovations. So since our data set lacks these features, even the most advanced models can't predict price perfectly. So latitude and longitude are two raw for location pricing. The dataset only provides latitude and longitude. There is no zip codes or neighborhoods. In reality, home prices are heavily influenced by specific locations. Two houses in the same city can have completely different prices based on the neighborhood. So, what will affect? Latitude and longitude alone don't capture localized price differences accurately. So, what will be the potential fix? So try region encoding by clustering location based on city or neighborhood. So high feature correlation can reduce model performance. Some features in the dataset are highly correlated, which can cause redundancy. Average rooms and average bedrooms are correlated. More rooms typically mean more bedrooms. Population and average occupations are correlated, which higher population often means more occupants. So, what will affect? The model might not learn independent relationships properly. So, what will be the potential fix? Use principal component analysis, also called PCA, to remove redundant information. So, the fifth one is XGBoost is powerful but has limitation. XGBoost is great at capturing interaction, but it's still a decision tree based model. It excels in handling complex relationships, but it's not always the best at modeling continuous linear relationships found in real estate pricing. So, what it will affect? Sometimes linear regression models like Ridge Regressions or Lasso Regression perform better for real estate data. So, potential fix is that stack XGBoost with Ridge Regression and Random Forest for better performance. So, small data set size, the data set only has approximately 20,000 records for all of California, and real estate AI model typically train on millions of records. Companies like Zillow use hundreds of additional features. So, what will it affect? The small data set size limits how well our model generalize. So the R square score is already strong for this dataset. Most research papers using this dataset report R square value between 0.75 and 0.85. Even real world Zillow, Redfin, and real estate AI models never reach 100% accuracy. So the dataset doesn't have enough predictive power to reach R square equal to zero point 0.9. So how to improve R2 further or R square? So if you still want to push R square closer to zero point 0.9, So try the following steps. The first one is feature engineering improvements. So need to create new features. For example, income and house age, average rooms divided by average occupations. So average room size per occupant. Create new features like median income into house age, interaction between income and house age, average room size per occupant. Then transform skewed features like apply log transformation to highly skewed features like median income and populations. Improve location features, cluster latitude or longitude into meaningful zones instead of using them as raw numbers. Try different models, combine XGBoost plus Ridge Regression plus Random Forest. Neural networks use a deep learning model MLP regressor. Try second degree polynomial feature. Tune hyperparameters more aggressively. Increase n estimators in XGBoost, for example, 20,000 plus trees. Use smaller learning rates 0.005 or 0.01. Perform feature selection to remove redundant features. Use external data for more features. If possible, add job growth rates in each area, crime rates per neighborhood, school quality ratings, Google Maps, API to get real estate neighborhood data. So, more data equal to more predictive power. So, final takeaways. R square of 0.83 to 0.85 is already strong for this dataset. Feature engineering, model staking, and hyperparameter tuning can improve performance. Reaching R square equal to zero point 0.9 may not be feasible without more data, so focus on minimizing root mean squared error for better real world performance. If you found this video helpful, smash that like button, hit subscribe, and drop a comment below. Let's keep learning together. Stay tuned for more Python and machine learning tutorials. See you in the next video.